Okay, please confirm once my screen is visible. Type S in the chat box. Are we good to go? Okay then. So this is our map interface hierarchy. So we have completed what is map interface. We have also completed hash map, linked hash map, identity hash map is also completed. Okay, so we will discuss about this weak hash map in the last. So we need to understand something about garbage collection. So this topic will be discussed after completing the remaining classes and the interfaces. Okay, we will park this for the discussion after completing all the classes. Right. So today we will understand the functionality of the sorted map and the navigable map. So both are the interfaces. So let us try to understand each and every interface. Firstly, let us go with sorted map. Okay. So by looking at the diagram, we have a conclusion here. So sorted map is a child interface to map interface. Sorted map is an interface, it is a child interface to map interface because sorted map extends to map interface. So the point that we have just by looking at the hierarchy is what? Sorted map is a child interface to the map interface. First point. Okay, when it was introduced in JDK 1.2 version. Okay, this is not a legacy interface, so it is introduced in 1.2 version. Okay, the third point is, so just remember one thing. So this sorted map, if I go back to the diagram, so this sorted map, this navigable map, this tree map, and these are just similar to what? These are just similar to sorted set, navigable set, and tree set. They are just similar to sets, but here the data will be in the form of key value pair, right? That is the only difference. Apart from that, and you are going to see some new methods, but the functionality is going to be same. They are just similar to sorted set, navigable set, and tree set, right? So it was introduced in the year, introduced in JDK 1.2 version. And the third point is the data will be in the form of key value pair, isn't it? So it is going to store the data in the form of key value. Okay, you can store the data, but this data has to be represented in key as well as value. You need to have a key and you also need to have a value. This combination is mandatory for the sorted. Right. The fourth point is keys are always unique. Please be informed that. So we know these things already. Keys are unique. Keys must be unique, and the values can be duplicated. Okay, at any point of time you cannot have the duplicate keys. They must be unique always. So this is one of the takeaways. And the fifth point is by default sorted map does not follow insertion order. We will understand each and every point in detail by taking a simple example. Okay, so by default sorted map, the name itself says sorted map is meant to store the elements, or mean to retrieve the elements in the sorted order, retrieve the keys in the sorted order. So it does not follow the insertion order. It will never follow insertion order. Sixth point. Okay, and again there is one more point we have. By default sorted map follows sorted order. The name itself says, its name is what? Sorted map. It means it is going to follow the sorted order. Or I can say that sorting order. Follow sorting order. So all the keys with respect to keys, I am discussing everything with respect to what? Keys. With respect to keys. With respect to keys. Everything is with respect to keys. By default, and one more point I can make, your sorted map allows only the homogeneous element. There is no concept of heterogeneous element that is applicable for sorted map. Sorted map allows only homogeneous element. Homogeneous means the same data type. Homogeneous. Okay. 8th point. By default, sorted map does not allow the null keys. Does not allow null key. Not even a single null key is allowed in the sorted map interface. Okay, 9th one. And by default, it allows okay, let me copy this. I think this theory is very boring. We will jump into the practical concepts in a short period of time. The sorted map always allow comparable objects. Okay. So you know what is a comparable object? We have discussed this comparable objects in the comparator and the comparable interfaces. So refer to those topics if you have any doubts about comparable objects. Any class that is extending to the comparable interface is called as what? Comparable objects. Okay? So these are the 9 points that we have. Okay? Let us understand this in the practical program. So what is the interface that we are discussing about? The interface that we are discussing about is what? The sorted map. I'm sorry. Okay, we are discussing about the sorted map interface. Okay, so the sorted map is an interface. So you cannot use what? You cannot create an object for the interface. So all the highlighted part is interface and all the non-highlighted part is the classes. So you cannot create object for the interface. You need an implementation class to create object. What is an implementation class for the sorted map? Tree map is the implementation class. Okay, so this is how I can, with the help of tree map, I can create an object and I can refer it to what? I can assign it to the sorted map type. So this is the combination. This is the combination that we need to use to to work with the sorted map interface. So the program is, so I need to create sorted map. Okay, the key value. Okay, I want to take a kind of real-time example. For example, for the key, I am considering it as integer. Okay, and the value I want to take it as string. Both are generic types. Right? I am taking the reference variable as rank. I need to create object for the implementation class, which is what? What is implementation class? Tree map. Okay, so first line is very clear. The reference variable has been created on top of sorted map, and the object is created with the help of implementation class, which is tree map. Okay, I want to store some data in the form of key value pair. So the rank is representing key value pair. So I need to use a method called put method. So we know what is a put method. It is going to add data in the form of key value pair. Okay, the key is going to be a numerical number. Let us say that the key is something like 5, rank 5. Let us say that Ratna has secured the rank 5. Okay, don't worry about the numbers. And I am taking another rank 2. Let us say that Jyoti has secured second rank, like this. I want to create, 3 more ranks. So let us say that there is rank 7. Okay. Let us take it as Sagar. Sagar has secured rank 7. And rank 9 let us take. So 9 is secured by Yashwant. And let us take a rank like rank number 3. So 3 has been secured by Venkatesh. Right? So this is the data. So if you look at the order is what? The first key value pair is 5. The key is 5, second key is 2, 7, 9 and 3. So let me print this. And I want to print the reference variable rank. Okay. So no matter how the order is, the output is always sorted. See, output is arranged in the sorted order. Actually the insertion order is different. We have inserted 5, 2 followed by 7, 9, 3, but the output is sorted. Automatically it is getting sorted. Why it is getting sorted? This is an internal design. That is how sorted map has been designed internally to ensure that all the keys get sorted, no matter how the values are added. For example, let us say that I am adding, instead of 2, I want to, instead of 9, I want to add -9. Okay, so it will be sorted again. -9 comes first, followed by 2, 3, 5, 7, ascending order. It is following the sorted order of ascending type. Right? So by this, I can make a conclusion like, this point is giving some justification, isn't it? By default, sorted map follows sorted order with respect to keys. Do you think values is getting sorted? Values are not getting sorted. Only keys are getting sorted. Understand that? Only keys are. This concept is applicable only for keys, not for the values. Okay. First point. Okay, it is not following insertion order, right? Because output is sorted. So it is ideally it is not following what? Insertion order, no matter what. Right? So for this, the justification is also given for the point number 5. By default, sorted map does not follow sorted insertion order with respect to keys. This has been justified. This has also been justified. Right? Let us try to understand this. Please be informed that keys are unique, values can be duplicated. I can have duplicate values, guys. I can have duplicate values. I can add one more Venkatesh. And I can rank the second Venkatesh to the number 20. Okay. So no matter what, you can duplicate the values. So there are 2 Venkatesh, and look at the order. The order of the first Venkatesh is with respect to the given key. Okay, and the order of the second Venkatesh is also with respect to the given key, which are sorted to each other. Right? What if I try to duplicate keys? Okay, I am trying to duplicate key number 9 once again, and this time I am giving a name like Balaji. So when I try to duplicate key, what is happening? The existing key is getting replaced by the new key. So I can conclude that duplicates are not allowed. If you try to add a duplicate key, it is going to replace. So this is the duplicate key because I am adding it for the second time. So this duplicate key is going to replace the value which is Shashwant. Shashwant is getting replaced by the new value Balaji. If I add another duplicate key, same duplicate key once again, this time 9 instead of Balaji, let me write it as Srikanth. Right? So now this is the duplicate key and the value will be replaced. So latest duplicated value will be arranged in this sorted set, in this sorted map. So Srikanth is coming here. There is no Balaji and there is no Shashwant. This is one more conclusion, right? This conclusion is again giving a justification for this point number 4. Right? And look at this point number 7. By default, sorted map allows only homogeneous element. Means, can I add heterogeneous? When I say heterogeneous, so here the generic type, first type is integer, second type is string type, right? And to understand heterogeneous, we are not supposed to use the generic type. Let me remove the generic type. Okay, so I'm trying to add something like Okay. Now all the keys till line number 20, all the keys are in the numerical form, but in the line number 21 I want to add a key which is of string type, something like first or one. Okay. As per our understanding, one is a number. When I say one, okay, you think it is a number, but as per Java, this one is not a number anymore. Even though it is spelled, it is pronounced as one, but it is not a, it is not, it can't be integer. It is a string type, right? And in place of rank, okay, let me take something like Anil. Okay, if I run this, we are getting an exception. Class cast exception. Why we are getting class cast exception? We started adding a number in the key. We started adding a number in the key, right? And we are violating. What kind of violation we are doing? We are changing the type to a different type. So till line number 20, the key is in the form of number. But after line number 20, so you started adding string. So you started adding integer, okay? And if you are trying to choose one particular key and value, we should follow that till for all the elements that you are going to add. To try to make any change, you get what java.lang.ClassCastException, because this combination, we call it as what? The combination of different data types in the keys as well as in the values. This combination is called as what? Heterogeneous combination. This is not all. Only homogeneous combination is all. Right? And what is it? And if you violate, or I can say that if you add heterogeneous element, you will get java.lang.ClassCastException. Okay, and this point, okay, this point needs to be visualized, right? So you cannot add null key. So we try to add, let us try to add a null key and let us see what will be the error. Okay, I want to add a key like null. Okay, let me run this. Okay, when you add a null key, you get what? Null pointer exception, java.lang.nullPointerException. You add any null key, you will get. So we will also understand about these internal things, why it is not accepting null key, why it is not accepting the heterogeneous element, how it is following the sorted order. These things has been discussed already in the sorted set and the navigable set in our previous classes. Okay, same thing we are going to discuss once again. So please focus here. Okay, we will get what exception we will get? Java.lang.nullPointerException we will get. Okay, at this point, I think you are clear with this point, because the string object, all the objects, I mean all the type, all the generic type that we are adding here are comparable objects. Example, the integer type, integer is extending to comparable interface, so it is a comparable type, and the string is also extending to comparable interface, so it is also what? Comparable type. We have discussed these things in our previous session. Okay. One more person is missing here. So let me add that person. Okay, we will see some methods, some significant methods on top of sorted map. We need to place a rank here. Let us say that something like 14. Let us give 14 or. Don't worry about this rank. This is for the example. Just for the example. Okay. Now let us try to add a null value. Let us see whether a null value is accepted or not. Null key is not accepted. Okay, let us try to understand if null value. So you can add null value. Only the problem is with the null key. You are not supposed to add the null key, but you are allowed to add what? You are allowed to add null value. Right? Let us make this point here. Please be informed that you are allowed to add the null value. That's it. These are the major points that we have for the sorted map interface. Okay, let us understand about some of the significant methods on top of sorted. Okay, so this will be very interesting. Let us try to find the methods. Let me remove this. Let us keep Venkatesh here. Okay, when I run this, we will get the empty output. Okay, already it is there now. System. Okay, now you see. Let me introduce some methods. Methods in sorted map. Okay, the first method is first key method. There is a method called first key method. Use that method on top of the reference variable rank. Rank dot. The method name is first key. Very simple. The moment you give first key, it is going to return the key value. It is going to return the key of the first key value pair. What is the first key value pair that we have here? 2 followed by Jyoti. Right? It is going to return the key 2. 2 will be written in the console. Right? So if you want to imagine this in the paintbrush, if you want to visualize this in the paintbrush, this is our actual code, isn't it? So we have the actual code, and so this is the order that we have placed, and after sorting it, the sorted map is going to sort every element, isn't it? Right? No matter how you add it, okay, at the end of the day, everything will be what? Sorted. Okay, these are the values that you are that we have. I want to increase the size. Okay, so we have the 1 to 5 key value pair combination. Okay, so first method is what? First key method. It is going to return the first key. The moment you call the moment you call this first key method on top of the reference variable, so what is the key of first key value pair? Okay, what is the key? 2 is the key. So 2 will be returned to the console. First 2 is the key. Right? Like this, we have some more methods. Like we have a method called the last key method. Okay, when the first key is returning first key of in the key value pair, the last key is going to return the last key of the key value pair. Right? So when I run this code, you get 14. Why you are getting 14? Okay, what is the last key value pair that we have? This is the last key value pair that we have. Okay, what is the key of the last key value pair? 14. So 14 will be displayed on the console. Right? So this is the second method that we have, last key, and we have another method called system.out.println, like something like headmap. Rank dot headmap. Okay, in this headmap, it will accept an object. It will accept the object. You can pass any key here. For example, if I am passing 7 here, okay, what it is going to do is, it is returning something like 2 Jyoti 5 Ratna. I am passing a key called 7 here. Let me repeat. I am passing a key called 7 here. It is returning something like 2 Jyoti 5 Ratna. Let us visualize this in the in the diagram. So this is my, I am calling the headmap method, and I am passing a parameter of integer type, which is 7. Okay, firstly, it will try to identify, is there any key with 7? With the key number 7. Is there any key? Yes, it has found there is a key called 7 here. Okay, and it will return. It is what the name of the method is headmap. It is going to return the previous set of key value pair elements. So what are the key value pair elements that we have before 7? Okay, these 2 are the key value pair elements. So 2 Jyoti 5 Ratna will be written in the console. Okay, so what if I pass something like 6? So 7 is there, no issues. What if I pass something like 6? If I pass something like 6, what is the output that we get? If 7 is there, no issues. If I'm passing 6, we are getting the same same key value per elements in the console, because first it will try to identify, is there any key like 6? Is there any key like 6? It will try to identify. Okay, there is no such key. There is no such key. You have 7, you have 5, but there is no such thing like 6, right? But if you just understand what is the placeholder for this 6 number, it will fall in between 5 and 7, isn't it? This is going to be the imaginary placeholder for the key 6, isn't it? Right? And the numbers that are lesser than 6 will be returned to the console. These two are the keys that are lesser than 6 that will be returned to the console. So this is the functionality of what? This is the functionality of HTML. Right? Okay, what are the methods that we have discussed so far? First method, public object, first key method. Second one is public object last key method. Okay, and the third method is you have what? Public sorted map, get map, and you are going to pass an element in object. You will pass a key. You will pass a key object, right? And there are a few more methods that we want to understand. So head map is there. There is a method called a tail map. Tail map. Okay, I want to find the tail map by passing a key as let us pass something like 5, right? So it is displaying something. Okay, you are passing the number 5 in the tail map method. As a parameter, you are passing the number 5 in the tail map method. Right? What is happening behind the scenes because of this instruction? Let us visualize this. Okay, so you are using a method called tail map. Tail. Okay, you are passing the number 5. Okay, it will identify, is there any key with 5? Yes, there is a key with 5. Okay, now this time it will consider the key of 5 itself. Along with that, it is going to consider all the elements that is falling after the key 5. So this will be written in the console. Previously, it was not considering the key that we have passed. That key was ignored in the head map. But here in the tail map, that key will also be considered. Along with that, all the values that are falling after that particular key will be displayed in the console. Okay, for example, if I'm passing something like a key, something like I want to pass something like 8 here. Here is the second example, 8. So 8 is a number, 8 is a key, and there is no element with the key 8. Right, no such 8 key here. Okay, we have key like 5, we have 2, we have 7, we have 9, we have 14, we have, but we don't have something like 8. Right, what will happen behind the scenes? Okay, the JVM will try to identify, is there any key with the number 8? It is not there. It is not there. Of course, when it is there, it is going to have this as a placeholder. Okay, it is going to fall between 7 and 9. Okay, since 8 is not there, it will ignore that and it will consider the remaining elements, which is 9 and 14. So 9 and 14 will be displayed in the console. Saswant and Venkatesh. Okay, if it is that will be included. If it is not that will be excluded. As simple as that. This is the functionality of what? Tail map. Okay, what is the name of the method? Tail map. Fourth method, public sorted map. And the name of the method is what? Tail map. Tail map. Okay, and fifth method, this is also one of the important methods. Okay, we have a method called submap. Sorted map, submap, and you can pass the from key and the to key. From key, object, to key. By using the method called submap method, what we can do, you can pass, it will accept 2 parameters. submap. Okay. Let me pass the values like 5, 5, 14. Okay, sub. I am passing two keys. One is key number 5, second one is key number 14. Okay, from key and the to key. Let us see the console. Okay, so you are getting something like, okay, 5 is considered, 7 is considered, and 9 is considered, but 14 is not considered. It is ignoring the to key and it is printing just before the to key. The value, the key value pair that is falling just before the to key. If you want to imagine this, if you want to visualize this, remove all this. So this is our actual piece of code. Okay, I'm calling submap method on top of rank. So we have passed two keys here, isn't it? The key number 5 and the key number 5. Okay, is there anything like key number 5? Yes, there is key number 5. It is here, right? And is there anything like key number 14? Yes, there is key number 14. Okay, it is here. Okay, but it will not consider key number 14. Instead, it will ignore the key number 14. It will just include the element that is just falling before the key number 14, which is 9. So these three elements will be displayed in the console. 5, 7, 9. Aren't we getting the same answer? 5, 7. If I want to find 2, 20. From is 2 and the 2 key is 20. Okay, now if you see the output, you get all the elements, you get all the key value pairs. Why you are getting all the key value pairs? Let's try to imagine this. Okay. So this is our latest piece of code. Okay, so we have passed two parameters. One is 2 followed by 20. So is there any 2 here? Yes, there is 2 here. It is going to consider this. Okay, along with this, is there any 20 here? Okay, there is no 20 here. If there is 20, it is going to be here. Okay, as per our imagination, 20 is always going to be after 14 with respect to ascending order, right? So this will be ignored. This will be ignored, and the element just before this will be considered. So the output will be from what? 2 to 14. So this will be displayed in the console. Right? Let us do some more experiment here. What if I try to do something like 20 and 2? Is it a valid combination? From is 20. You are getting illegal argument accuracy. Always ensure that since you are dealing with the ascending order, the first key should be in the lower number. I mean, you can use the smaller number than the last key. Okay, if you are using 2 here the key must be greater than 2. Okay, please ensure this. If I do 2, 9 here, okay, so what are the elements that we have? 2 will be included, 5, 7, 9 will not be included, 9 will be excluded. First key will always be included, the second key, the last key or the 2 key will be excluded. Okay, if I do 14 here, 2 will be included, 5 will be included, 7 will be included, 9 will be included, 14 will be excluded. So this will not be considered. If you want to consider 14 also, you need to give us a number like something like 100. So 100 is not there. There is no such key like 100. But if 100 is there, it is going to be here, somewhere here, after 14. So all these elements will be displayed in the console. Are you getting this? So this is all about what? This is all about the sorted map. Have you all got this, everyone? Type yes or no in the chat box. You just want to join today's class, okay? Okay then. So this is all about the sorted map. So we will understand the importance of what navigable map, right? So let us go back to that code. Navigable So this navigable map is very easy. By looking at this diagram, let us make some points about navigable map. We do not want to deal with this. So navigable map is positioned here, guys. This is where the navigable map is. So navigable map is an interface. Okay, it is extending sorted map. So I can write a point here. First point, navigable map is a child interface to the sorted map. First point. Okay, what is the second point that I can make? It was introduced in JDK 1.6 version. Okay, it is very much similar to sorted map. It is very much similar to sorted map. However, it has its own specific methods. However, it has its own specific methods to deal with. Okay, you can write all these points. Okay, all these points are applicable for sorted map. You can include all these points. Okay, and I need to change the numbers to 4, 5, 6, 7, 8, 9, 10. Very much similar to sorted map. Only you need to change a few things here. Okay, wherever you have sorted map, changes to not this one, changes to navigable map. That's it. Right? Now methods inside. Navigable. Okay, so to understand about this navigable map, we cannot create an object for the navigable map. Why? Because navigable map is also an interface. You cannot create an object for the interface. So I am going to use tree map for the, because it is an implementation class. So let us go back to the code. Just change this to what? Navigable map. Okay. So I'm going to have the same key value pairs. I'm not going to change this. And let me remove this. Let me run this first. So navigable map is also going to follow what? Sorted order. No difference. I have just mentioned it, right? It is just similar to sorted map. So all the functionalities of sorted map is also available for the navigable map. Same qualities it has. But there are some few extra methods. Inside navigable. What are the methods that we need to discuss about navigable? Okay. The first method, system.out.println. Okay, there is a method called rank.descending key set, or I can say descending map, not key set, descending map. Okay, so when you try to print the reference variable after adding key value pairs, after adding the elements, or after adding the data which is of key value pair, and when you print the reference variable, you get this is going to give you what? Give you the output in the sorted order, which is ascending order. But I don't like to give, I do not want to get the output in the ascending order. If I want to get the output in the descending order, I have an option. How I can get that? I can use the method called descending map method, which is going to give me the output in the descending order. This time, Venkatesh, the key 14 is coming first, followed by 9. This is just reversed. Okay, this is sorted. This is also sorted, but this is ascending order. This is sorted in descending order. In order to get the key value pair in the in order to get the keys in the descending order, not value. In order to get the keys in the descending order, right? You want to go for what? Descending map. Getting this? So this is one of the methods that we have. First method is what? Descending map. So public navigable map descending. Just by using this method, you get all the keys in the descending order. The second method, so there is a method called ceiling key. Okay. You are not going to use change this reference variable. It is going to be rank itself, followed by you are going to use a method called ceiling key. You want to pass a key here. For example, let us say that I am passing a key like 9. Okay, so 9 key is as a value +1. If I run this, it is going to return me 9. So it is not making any sense. You are giving 9, it is returning 9. Okay, let us give 7. Okay, it is going to give me 7. It is not making any sense. It is just like you are giving the key and you are getting the same key as output. No, this is not the case. For example, if you want to give something like 11 here, key is 11. Just focus here. We are giving the key like 11. Okay. Is there any data, any key value pair with the key as 11? There is no such thing. Okay, so let us try to visualize this. So this is our data, right? I want to increase the font size. It is very big font size. 26 is also big. Let's go 26. It is fine. Okay. So I'm trying to use the key ceiling, ceiling key method, and I'm passing the key as 11. Right. So this is our code. 11. First, JVM will check is there any element like 11. Any element like 11. Is there any element like 11? So let us run this. What we are getting? We are getting 14. Okay, now you tell me, is there any element like 11? Okay, this 11, okay, JVM will try to identify. Okay, let us try to check, is there any element like 11? Because it is sorted, it will start from checking from 2, 5, 7, 9 and 14. 11 is missing. It's not able to identify 11. 9 is there, 14 is there, but 11 is missing. That missing 11 is going to occupy this position, don't you think so? Okay, it has found that if 11 is not there, but if 11 is there, it is going to be between 9 and 14, isn't it? It is going to be somewhere between 9 and 14. So this is the place of 11. This is the place of 11. Okay, what is the name of the method that we have? Ceiling key method. Ceiling means top. Ceiling means higher. You have ceiling fan, right? Where we install, ceiling fan on the floor, no, right? On the roof, right? Like that. Ceiling means higher. So what is the first element that is after 11? 14 is the first element, right? So this will be written in the console. Are you getting this? Okay. For example, if I want to use the key ceiling method on top of 5. 5 is there, so this will be written. If it is there, that will be written. So you don't get, you won't get much thing here because it is not making any sense. If I give 3 here, 3 is not here, but if 3 is there, it is going to be after 2. Somewhere around, somewhere between Jyoti and Ratna, the key is going to be here. Between 2 and 5, 3 will be here. So what is the highest value after 2? The present value, 5. 5 will be written to the console. Getting this? Right, so this is the functionality of ceiling key, and you have another method called hierarchy. So this is hierarchy. Okay, let us try to find what this hierarchy is returning when you pass the key as 9. Okay, so you are passing 9. This time it is not considering 9. Previously it was considering the 9. It is going to return the 9 itself. But if you pass 9, it is returning the key that is just after 9. 14 is it is returning. Likewise, if you pass 5, okay, this hierarchy is not going to return 5. It is going to return the value, okay, the key that is after 5, that is bigger than 5. According to us, after the key 5, 7 is bigger, okay. 7 will be returned to the console, higher. Right, if you pass something like 8, so you don't have 8 here, you have 7 and you have 9, okay, and still it is going to return 9 only, because 8 is somewhere between 7 and 9, so that will be ignored and 9 will be written. This is just a small difference between ceiling key and the hierarchy. Want to visualize this? Same like this. Okay, and okay, delete. Okay, this is the hierarchy method, and you are passing 8. Okay, this JVM is will try to identify is there any key with the value 8? No such key. But if there is something like 8, so it is going to have which position? It will be somewhere between 7 and 9, isn't it? Going to be here. The next element, okay, the latest element after this will be returned to the console. The latest key, which is 9. That's why you're getting what? 9 in the console. Right? So this is the functionality of hierarchy. So there is another method called floor. You got to know about what is ceiling key. You should also have to know what is floor key. Okay, when I pass 14, guys, 14 is meant for Venkatesh. So I'm using a method called floor key. Floor means bottom or below. You're getting the same. 14 means when you pass 14, you're getting 14 itself. When you pass 9, okay, you get what? You get 9 itself. When you pass 7, you get 7 itself. It is not making any sense. Right? When you pass 11, is there any key as 11? There is no 11. There is no 11. Right? But what you are going to get in the console? You will be getting 9. Why you are getting 9? Let us visualize this. Okay, so this is our logic, which is what? Floor key. We are calling floor key method by passing 11 as the value. JVM will come into the picture. We will try to search for 11. Okay, 2 is there, 5 is there, 7 is there, 9 is there, 14 is there, but 11 is not there. Okay, if there is any key like 11, it is going to have this place somewhere between these two. Right? Floor. Okay, ceiling means this will be considered. Floor means this will be considered. That's it. Ceiling key means 14 will be written. Floor means what? 9 will be written. Getting this? Right? Floor key. Like this, you have what? Instead of floor, there is another key called lower key. Okay, there is a minute difference between lower key. So when you pass 11, you will get 9. But when you pass 9, you don't get 9. 9 is meant for Shashwant. You will get an element that is just before 9, which is 7. When you pass 7, you will get the key that is just before 7. Okay, 5. The real-time example, you will be using this especially when you want to get some data that is already sorted, and if you want to get some data in the sorted set or in the sorted map, okay, you will use this kind of functionalities. Right? So lower key is also we got to know what is lower key, and the last and okay, one more method is there. This is very famous method. Poll first entry. This poll first entry is a very culprit method because it will just return. You are getting 2 and Jyoti, poll first entry. Okay, and when I try to print the the reference variable after using this poll first entry method, okay, the first element will be removed and the remaining element will be included. Okay, it is going to remove the first element, first key value per data. Right? Visualization is very simple, guys. Okay, so this is our actual code. Let me remove this. Okay, I am using this is not the one. Okay, I want to use the poll first entry method. What is the method? Poll first entry method on top of what? Rank reference variable. What it is going to do? It will first, what is the first element? First key value per element, Jyoti. This will be removed, right? And it will return that, and that will be removed, and remaining data will be displayed to the console. Right? Likewise, we have the another method, okay, which is going to do the opposite. Instead of first element, we are going to remove the last entry. Poll means removing. That's it. Poll last entry. Okay, let us run this. So now the Venkatesh is removed. Right? First means the first key value pair will be removed. Last means the last key value pair will be removed. The same thing. Okay. Same thing. So what is the last key value pair? You are not passing anything. Okay. In this object, what is the last key value pair that we have? Venkatesh. 14 and Venkatesh. 14 is the key. Venkatesh is the value. This will be removed, and the remaining elements will be. Okay, so these are the prominent methods that we have for what navigable map. What are the methods that we have just discussed? We have public object, ceiling key method, ceiling key. Okay, you pass an object of what type? Key type. Okay, what is the third method that we have? Public object. What is the method, guys? Hierarchy. Hierarchy, right? And what is the fourth method that we have? Ceiling key, hierarchy, floor key. Okay, what is the fifth method that we have? Lower key. Okay, what is the sixth method that we have? Here you don't pass anything, will not accept any parameter. What do you get? So 4 first entry. Okay, what is the seventh method that we have? 4 last entry. Okay, so you will be using this. There are a lot of use cases for this navigable map and sorted map. So in the real-time application, there are some places where you will be depending upon what this navigable map interface, especially in order to manage the database query results. When you are dealing with the database, when you want to organize the database query results in such a way that you want to consider the people, if you want to consider the data only just before few elements, like by using ceiling key, by using hierarchy, you can organize the data by using all these methods. So to manage the database query results, and you can also do it for event handling, right? And this can also be used in the financial applications, mostly financial applications. When I say financial applications, so there will be, like, you will be dealing with huge amount of profit information, huge amount of losses information, or company information. That company makes a lot of profit. Okay, when I say financial applications, it can be anything. Like it can be what the stock market application, right? Where you see profits, where you see losses, where you see gains, where you see such graph things. Right, when you want to find the profit of some companies, such as that is just below the specific saturation limit, you can do that by using this navigable map interface. It is used in financial applications, and it is also used in in the daily database analysis, data analysis. And fifth thing is, I think it will be used in scientific computation. Scientific computations. Okay, these are the major use cases of this sorted map and the navigable map. Right. So this is just for your reference. Okay. So firstly, we will try to use this in Java. Then we will understand all these things. Okay. This will come on the go. When you start working, so these things will come. Before now, try to understand how these methods can be used and how it can be utilized. That's all about the sorted map and the navigable map. Tomorrow we will complete the tree map, because it is going to take a lot of time. We need to understand the internal things of tree map. Then what else we have after tree map? We have hash table, and we have property files. Okay, and we have CV cache. Then the collection topics will be over. Do you have any questions for me? If you have any